Alright, example 2. Consider the triangle formed by the points A, B, and C. So, I don't really care what it looks like. You can really graph it on your dot points if you really want. All I do know that ABC makes a triangle. But I don't really care what position it is in. First step, use the distance formula to classify the triangle as equilateral, isosceles, or scalene. Okay, so basically what we have to make sure we do is, obviously we need to find out the differences. Hopefully you know that equilateral is 3 sides same. They all have the same sides. Isosceles is 2 sides that are same. And scalene just means all different sides. Right, they're all different. So we basically have to figure out the length of the sides. So, you know, length AB over here, length AC over here, and length BC over here. So we've got to figure out 3 lengths and see if basically if they're all the same, only 2 of them are the same, or if they're all different. Right, so if you have a read of this little box over here, basically the distance formula saves us having to graph it. So that's why I said it doesn't really matter how I graph it, because it actually doesn't matter. Because I'm just going to deal with the mathematics. Alright, so let's use the distance formula. Step 1, what do we always do? Label. Alright, we're going to label these. So I'm going to choose this one first, 1. So length 1. Length 1 is what I'm going to do over here first. And that's my length AB. So distance is, well, first of all, let's write the coordinates that I'm dealing with. A, and then B. Oop. These are the coordinates I'm dealing with. Alright, first step was label, so I'm going to label them. X1, that's Y coordinate 1, that's X coordinate 2, this one's Y coordinate 2. Alright, step 1 done. Step 2, write the formula. Alright, the formula is simply D equals, so if you need to scroll up, go scroll up and have a look at it. But I just know it off by heart because I used it many times. So you'll get there one day too. But just copy it down by looking at the formula. Alright, step 2 is done. Step 3, substitute. Remember those 3 steps. So all I have to do is write D equals square root, and then make sure I substitute in the right value. So x2, have a look, it's 2. Make sure you put a minus there. x1 is 1 squared. There's a plus there. There's a bracket there. y2 is 5 minus y1 is 2. So that's done. All I have to do is solve this. Alright, that's all I got to do. So my D is 2 take 1 is 1. 5 take 2. 5 take 2 is 3. Right, again, solve it. 1 squared, that's 1 times 1, which is 1. 3 squared, which is 3 times 3, which is 9. Right, so D is square root 1 plus 9, which is square root 10. Right, so that's what I got for length 1. I might just squeeze it under here so we can make more space for the next ones. Oops. So my D is square root 10 units. Right, that's what we already have. Alright, let's try the other example. So that's length 1, let's do length 2. So in my diagram I said my length 2 is A and C, so I'm going to use A and C. My A is 1, 2, my C is 4, 1. Alright, so again, step 1, label it. So x1, y1, x2, y2. Step 1 done. Step 2, formula. Right, I've got it right here, so I'm not going to copy it again. Step 3 is substitute. So here we go. D equals, so you only use these values over here that we've got copied it down, because that's this specific length. Alright, x2 is 1. That's not right, 4. x1 is 1. Alright, y2 is 1. y1 is 2. Alright, all I've got to do is solve it. 4 take 1 is 3. 1 take 2 is -1. Alright, 3 times 3 is 9. Now you got to be careful. If you don't put a negative, if you don't put a bracket around that negative, and if you put that in the calculator to figure it out, you will get the wrong answer. So make sure if there's a bracket, you put a bracket in. So -1 times -1. Negative number times a negative number actually turns into a positive one. Alright, so it'll be square root 10 units. Well, have a look. So this one's square root 10 units. That one's also square root 10 units. So we know that at least two sides are already the same. Let's do the last length 3. So oh no, it's not A and C anymore. It's we're doing B and C. So I've got to copy the B, which is 2, 5. C, which is 4, 1. So now I've got to do this last one. So it's a bit of a lengthy process, but it's not a hard one. Alright, I don't have to copy down my equation again because it's already there. Let me just substitute those values in. X2 is 4, X1 is 2, Y2 is 1, Y1 is 5. Alright, let's keep going. 4 take 2 is 2. 1 take 5 is -4. Alright, so let's try this. 2 times 2 is 4. -4 times -4 is going to be positive. Let me just change this. Positive 16. Alright, so the last one is square root 20 units. So as you can see, the last one doesn't agree. So, therefore, I can actually conclude, if I do a little concluding sentence, therefore, triangle is going to be an isosceles. How do I spell that? Because only two sides are the same. Isosceles. There we go. Now, what we're going to do is determine whether the triangle is right-angled. So, obviously, that is using Pythagoras. So I'm going to make a little box here and we'll see if we can fit it in here. So Pythagoras. So if you're watching at home again, copy everything down. This is a good example. Pythagoras theorem allows us to know if a triangle is right angled. So if I just do some little notes, if my triangle is right angle, my longest side is C, these are A and B, I don't really mind. And the equation that works is A squared plus B squared equals C squared. Now, looking at these, we always know that the C over here is the longest length, and looking at our length, we know that square root 20 should always be the largest length. So if I square that number, and then add the other two, so other two lengths are the same, square root 10 squared plus square root 10 squared. If I do these, it should equal each other, and if it does, we know that the triangle is right angled. So let's have a go. Well, first of all, there's a square and a square root, so they cancel out. So 20 equals, there's a square and a square root, so it cancels out 10. There's a square and a square root, so it cancels out 10. So does 20 equal 10 plus 10? Well, it sure does. So therefore, right angle triangle. Because a Pythagoras theorem worked. Alright, that's it.